Hello, welcome to my assignment showcase. Today I am showing the single round DES code implementation. I will discuss the code and the model step by step with slowly and steadily. So let's start. So here you can see the model where I have shown the single round of DES, and here it shows how it works, and here is my code, and I will show how my code works as I go through the model. So I have uh, sorry, my mistake. Here you can see in input we are taking 232 bits of what can we say, 232 bits of text, which has either come from plain text or another previous round text. So here the text, 64-bit text is divided into 2 bits, 32 bits and here 32 bits, and here taken the key which was initially 64-bit, and after permutation choice 1 it has become to 56-bit and divided into 2, which has given us 28 and 28-bit keys. So first let's talk about the keys, then we will do the each 28 bit of separated keys left shift by some rules. We will talk about the rules later, and then we will go to the permutation choice, and then that key will become 48-bit, and then it will go to the feastal function. Those left shifted keys will be the next rounds, another 28-bit keys, not the permutated ones, the left shifted ones. Okay, now let's see what will happen here. The left 20 left 32 bits of the key, no, sorry, left 32 bit plain text, which will go to a XOR function with something. So w- with what that left 32 bit of plain text will do the XOR, we'll go to that function, which we can see here in the right section. The right 32 bit of text will first be done in expansion permutation. After that, those 32 bits of text will become 48 bits, and it will do an XOR operation with the permutated choice 2 made it keys. Then it will produce 48 bits of a string, and then that string will go to the substitution box, and then it will become again 32-bit, and then there will be a general normal permutation, and then that output will be XORed with the left 32-bit text. Then that will become the next round's right text, and this initial right text will be the next round of the left text of the next round. Okay, that is the overview of the model. Now I will go step by step and show you how this code was implemented. So first, what we need a 64-bit left text and 56-bit key. So here you can see in the main function we have taken 60 bits character long, 60 character long text. Each character is 4 bits, so 60 character will be 16 character will be 16 into 4, which is 64 bit, and 14 character long key, which will produce 56 bit. Then those, and we need round number. Why we need that, we will talk about this later. Then we do the decimal to binary conversion, where I have shown you here in the first. This is my decimal to binary conversion. Here the string or the key, whatever I want, I can convert it to from decimal to binary, because we are calculating everything in binary. So here I am converting the key in binary, and after that what I am doing is, um, wait, please just a minute. Then I am splitting the key. So first what I'm doing is taking the 56-bit key input, then I'm splitting the key where we need 28-bit and 28-bit separately. Then we are doing the shifting. Now in the shifting section, I want to show you something that here you can see that when we want to do a left shift, if the round is 1, then we have to do shift left shift only once. If the round is 2, then once. If the round is 9, then only once. And if the round is 16, then only once. Or else all the round will do 2 left shifts. So in the code I have shown you that if round 1 or round 2 or 9 or 16, the shifting will be only 1 or 2. Then we will go to the left shift. I have the shifting function, left shifting function, sorry. I have the left shifting function here, you can see, and I have done here the left shifting. Okay, so after the left shift, now here comes the permutation choice. So after this one, this is the permutation choice 2 box, as you can see it from this one, this permuted choice 2 box. From this box, I have done the permute, and permute first I have to combine that left shifted and right shifted key to the 56 initial bits, and then I have to take this one and the permuted choice box and give the input of 48 key. So because it is going to compress it, so I am taking it in my function permute, which you can see here. Here, all the permutation, either general permutation or expansion permutation or substitution permutation, all are done here by just giving some needed informations. Like first, I have to give the string, then I have to give the array, which is the permutated choice box or the expansion. Like you can say that expansion permutation, substitution permutation, or general permutation box. Then I have to give how what will be my output box or the output size of that array, which will be um, what you can say 48 or 56 or 32, etc. So after doing the permutation, then what will happen? That 48-bit key will go to this XOR operation, which is inside the Feastel function. So initially our key component work are complete. Now what we'll do is inside the Feastel function. So here we have the permutated round key, and this one is binary format, and this one is that decimal format. So now I will go to the encryption part, which is in the Feastel function, and here you can see I have taken several inputs, and here at first I have made this plain text decimal to binary. First of all, we have to take that 16 byte character and convert it to 64-bit. Then after that we have uh, sorry, my mistake, that 60-bit character we have to make it 64-bit decimal character, and then that string will be divided into two parts, 32 and 32 bits. Here I have done those 32 bits of splitting, and after splitting I have also shown it in the console. I will print it after uh, sorry, I will print it after showing all the my code how it has worked. Now after doing this splitting, we have to take the right one and do an expansion permutation here. So this is the expansion box which is taken from here. As you can see here, expansion permutation box, and from this S, and you can see that S box is also shown here. Let me show you these first, so there will be no confusion later. This is the S box, and this S box is printed out here. This is the straight permutation box, which is I can show this here. You can see it, permutation function. So this is the straight permutation box, and after that, so our initially all the value or the inputs, initial inputs that we needed are shown. Now you can see what we have to do. we have to do expansion permutation. So for expansion permutation, we have to again call our that permute function. We have to pass our right, then expansion function, and sorry, expand permutation box here, this box, and then we have to put our desired key. So it will produce this 48-bit key, 48-bit string. So that right expanded string will be XORed with the right key, which was also in binary format, and this is right expanded key. Here, let me show you. This is my XOR function, and here the XOR operation is done. And after this one, we have to go to the substitution box. Now we have to do this one is little critical. This is the substitution box. Here what I have done is the substitution box method, which I can show you. If the value is 101010, then these four are the columns, and first and last value are the row. Then row will be 10, column will be 0101. Then the value of 10 is maybe 3, and the value of 101 will be something. So we have to calculate the row number and the column number, and find out here which row and column has that value, like it is in either S1 box or S2 box. Then we have to take the row value and the column value, and then we have to take that initial value and store it in the OP. So that is what I have done in this S box. And after that, the substitution box is complete, and again we have to do the permutation, which is initial permutation. And here you can see the permute function which I have used here. And after that, finally it will be XORed with the left plain text or left previous round text. So here I have passed the OP string and the left string, and I have done that XOR function that I have shown you before, and I have stored the left into X. Now I have also swapped left and right, because initially X will be right, so it is passed in the left because it will be used in round 15, which will be shown in full implemented DES. Not here, it is not necessary. So therefore that I have to swap those left and right. So the right will be the this desired value, and the left will be the initial right, and the new round key will be the before the previous 28-bit and 28-bit left shifted characters combination. So this is the previously left shifted key, which was you can see here it was wait a minute, it was combined here with the left shifted, and after that it is added as the new round key. So this is how the code works, and here you can see the output of it. So let me execute the code. Here you can see the console. So I have to pass decimal value of 16 character length. So one, so this is 16 characters, and this has to be 14 characters. And I have to enter the round number because of the left shifted operations. So let's say the round number is 4. And now you can see, after splitting, this is the left 4, which is this one. This is the right value, which is this one. And for after all these, the round 5, these are the round 5 values, as you can see, because if this is the li'th value, then it will be li plus 1th value. So if this is the round 4 left and right key, sorry, left and right text, this will be the round 5 left and right text. So here you can see the right text is as same as this one, and because you can see the right one straightly goes to the left, and the right value, you can see it is 4 character long, but if you do binary of this value, you can find 32-bit character. So it is okay. I will show you again it. And this one is the round key, which is converted from these 2 bits and done left shifted, and after that this round key is produced. So let me show you again the binary value of this one as 1. So it's the console. I'm giving the same value, 4. Here you can see it has produced 32 bit of string. So that is all about my assignment showcase. Thank you.